sweet. Great. So what are symmetry groups? What is symmetry? Yes.
Being exactly the same on either side.
Yeah, exactly the same on either side. Any other notions of symmetry? Yes.
When, like, you can associate the word congruent with symmetry.
Yeah, congruent. Yeah, same on either side. Yeah.
When half the image is the reflection of the other.
Yeah, when half the image is the reflection of the other. Right. Reflections are kind of symmetry. Any other thoughts about symmetry? I think you guys have already got this. I think you guys are already pros. So I came up with the notion that symmetry is a transformation which leaves a figure unchanged. So it looks the same on both sides, or if we took an object and reflected it, we get a similar looking picture. Right? So people love symmetry. It's like a big theme. You know, people tend to make cathedrals that are symmetric, or when people see a painting, they like the face to be symmetric. It's a major theme, but it's also a mathematical idea. So here's a simple thing, triangle, and I've labeled the vertices just so we can keep track of them as we move the shape around. Right? So imagine that that's actually a blank white triangle, and then the numbers are there just to keep track of which vertex is which. So what symmetries does this thing have? Maybe with hands, we can do some gestures. Yeah, I see a bit of this. Oh, I see some this. Nice. Okay. Yeah, I see a lot of lines, kind of mirrors, right? Oh, I see some of the stuff that would be good for that video game. We have to slice fruit, right? Yes. Okay, so we've got the reflections. Any other symmetries that we can see? Yes, here.
Rotational.
It's got a rotational symmetry. How many rotational symmetries? 3, right? We can leave it the same. We can rotate it. How many degrees? Is it 60 degrees? Or 120, right? It's a tricky thing, but yeah, I think it's 120. If we focus our attention on the center of the triangle, right, we'd be rotating that 1/3 of a full circle, right? So 360 degrees. You divide that up into 3 parts, we get 120 degrees. Okay, so right, you guys have got this. Great. Right, so there's one of those flips, right? The flip that interchanges vertices 2 and 3. Notice that this symmetry leaves vertex 1 sitting right where it is. Right, it flips, and it's right on top of itself. Okay. There is that rotation, right? That 120 degree rotation about the center. I guess we're going clockwise. Okay. So far so good. So we've got that. Okay. So mathematicians, their main purpose in the sciences is to make systems out of things. Right? We had all sorts of moves and like ninja chops to describe those symmetries, but we didn't have any formulas. And what mathematicians do is they come in, they see a natural phenomenon, and they make a system out of it. They introduce notation, they introduce theorems, and then the physicists and engineers can go and build stuff using those systems. Okay, so we're going to make a system for talking about those symmetries. Okay, so our first attempt will be to just write down where everything goes. Okay, so one way of writing down that symmetry. Right, so when we flip the 2 sides, the numbers 2 and 3 interchange. Right, so we can see that 2 goes to 3, 3 goes to 2, and 1 stays the same. Right, this describes everything that our symmetry is doing to the object. Yeah. What would happen if we flipped along the line through the vertex 2? What would happen then? How would it change? How would the thing change? Yeah?
2 stays the same, and 1 and 3 would interchange.
Yeah, right. These guys, 1 and 3, right? They'd switch, right? So we could write down, you know, different reflections in this notation. Okay. Nice. Okay. So what's neat about this is that it lets us do calculations of symmetries without actually having the object in hand, right? So at the University of Toronto, there was a professor, Donald Coxeter, who mostly studied symmetries of four-dimensional objects. And with four-dimensional objects, you're not going to be able to physically hold on to it. Yeah, so we need a technique for doing these calculations. Okay, so what I've written here is two copies of that same symmetry. Right beside each other. So we've got is everything visible? This thing's not in the way? Okay, sweet. So 1 goes to 1, 2 goes to 3, 3 goes to 2. Okay, and now we can start to multiply these symmetries, sort of abstracted or mathematically. Okay, so how do we multiply these things? We figure out where 1 goes. So 1 goes into 1, which goes into 1, which outputs 1. Okay, 1 stayed the same both times. Okay, 2 goes to 3, and now we look like this. So we take 2 goes to 3, 3 goes to 2, and 3 goes to 2, 2 goes to 3. So if we do this operation twice, if we reflect once, and back again, we should get a symmetry that does nothing. Right? So a symmetry that leaves every vertex the same. In this case, the math checks out. So we do our calculation. There. So far so good? Yeah? This is fine? Okay. What are these things really, these symmetries? Like, have you encountered anything like this in your high school class, maybe? No? Okay. Seems pretty unfamiliar. Does any, oh, yes?
Are there like matrices?
They are sort of matrices, yes. There's a way of representing permutations as matrices. And we've got some entries here. The multiplication's a little bit different than matrix multiplication. Yes, we can do that, yes.
They're kind of like functions.
They are sort of like functions, right? One way to think of this is a function that when you put in 1, it outputs 1. When you put in 2, it outputs 3. When you put in 3, it outputs 2. Right? So we could write down this down as a function, and we could say when x is 1, 2, or 3, we output, I don't know, let's call it f of x. Right, so we put in x is 1, we output 1, put in 2, put 3. So it's just a function way of thinking about it. Okay. Right. So yes, this neat fact that if you reflect twice, it cancels out. Okay. Now, I see a lot of phones but no notebooks. Could people get out pens and paper and stuff?
My bad.
No?
You might have left it in the.
Oh.
There's notepad apps on the phone, right?
Okay, sure.
You should draw with your finger.
Yeah, sure. Alright. So, yes. We don't have any paper in this room. Do we have pencils?
We have pencils all up. We can go get.
Okay, sure. Yes. Grab it. Yeah.
Grab a bunch of like pencils and.
We get you got it? You want
Jason's in there.
Amazing.
We're going to do a little bit of writing once the supplies arrive. So, if you're curious, I want to say a little bit about want to say a little bit about where you might encounter this stuff. So, so when I usually teach this stuff to my students, we do it in a course called Math 301, which is Groups and Symmetry, and we teach it in about third year undergrad. Okay, so today you're going to get a slice of what doing a third year math course is like at U of T. Yeah, has anyone taken courses here? I know some high schoolers do that.
What?
Yeah, you can do that.
Yeah, so so we do offer advanced placement for high school students. So if you contact the U of T math department and you finished, say, grade 11 functions, you can possibly enroll if you've got a recommendation from a teacher and a good average. You can enroll at U of T and take a course.
Take a college course or like another like high school course?
College course. Yeah, with the big kids. Yeah.
Good averages and how good?
Oh, yeah, I don't even know. Probably 80 plus.
We're good.
Oh, great. All right, yeah. I hope to see you guys here next year. Yeah, no, you guys can do that. Totally, yeah. Right, so if you're specifically interested in math, look up University of Toronto Math Department and ask if there are what's called an AP class, so advanced placement class.
Oh, AP. Is it, can we do it any like comp sci or anything else?
Yeah, so then you contact the comp sci department and email the comp sci department.
What if we're already taking an AP class at school? So like.
Right, then it's redundant.
Oh.
So how does it work?
Oh.
Right. So you would wind up getting like a spare class, usually towards the end of the day, and then you come to the U of T campus and take a lecture.
Wait, so you need a spare?
That's not happening.
No, you get a spare because you're doing the course in university, right?
Yeah, you're not doing one course. You're taking 4 courses a semester.
I can't free up my schedule like this.
No, but it's
Don't.
sorry.
I'm going to take a video. Freaking Vanessa said here was like snipe, so I was like, that's snipes are bad.
Right?
Well, we've got another question over here.
Doesn't like U of T offer like some like high school like something for high school students on like Saturdays in the winter?
Yes.
I remember seeing something like that.
Right, so yeah, U of T's got a ton of cool stuff. So one of the things that I tend to do is I do what's called a math mentorship. So you can sign up through the U of T math department outreach office. And the mentorship is you meet up with a professor or a graduate student and do some kind of research. So I had 2 grade 11 students last year, and we worked together. We just published an article about knot theory, which was kind of cool. So that's an interesting opportunity, U of T math mentorship. On Saturdays, there's also math circles. Math circles are at the Fields Institute, which is like just outside this building, just over there. And those are free. They're free. You just drop in on the Saturday afternoon, do some problem solving stuff. Yeah. Yes.
Wait, so could you explain the research thing a bit more?
Yeah, sure. Yeah. I love mentorship stuff. So to apply to the U of T math mentorship, you contact the outreach office, which is on the website, and your teacher has to write a letter on your behalf saying that you're in good standing, you haven't skipped too much class, and then you wind up getting paired up with either a professor or a graduate student. So I met with 2 grade 11s last year, and we did research on knot theory, so like strings and curves and stuff. And it lasts from February to April? February to April, no.
They end in June, I think.
Yeah, your classes end in June, right?
Mhm.
So it goes February to June. And you set up some kind of schedule with your mentor, and they'll offer various resources, read this book, try this puzzle, this kind of thing.
So like, how much math would you need to know to actually do this kind of like mentorship? Because like obviously the graduate student or like the professor is gonna be like doing some pretty advanced stuff.
No, we're not
No?
crazy. We
No?
know We know what you know.
Okay, then look.
So you can come into this even. I kind of want to turn off the camera. One of my students wasn't especially strong. You can come into this knowing what you know, and we'll find a project that's appropriate for you. We're not going to ask you to do the impossible. I saw like 5 more questions. So there's one way back here.
Do you know if there's mentorships for other as well?
That I don't know. Sorry, I'm like math only, but I can look into it. If you want me to look into it, I can. Just the person.
Turn off the high.
Sorry, can you speak a fair bit louder?
So
Thank
it's
you.
not that you're required to come in with
Yeah, you don't have to have a specific project. You just show up. You just show up, yeah. Yes. Yes. So it can count both as 15 credit and as a high school credit. Yes. I'm not sure. Almost, yes, probably, but I just don't know. I've never done that. But I can look into it.
When you look into it for her, you also tell me.
Yeah. I'll contact the people and I'll let everyone in camp know.
When would you apply for something like this?
December?
December?
One.
Because it starts in February.
And one more thing, I'm sorry. Would this be just after school or something? Or?
Okay. Not during school.
And you'd have to come here or?
You can set up wherever you and your mentor want. I met here with my students because this is where my office is.
She didn't act like it. I feel like most partners in science especially.
It's just hot.
Yeah, so we've got some stuff. If you're still holding on to a question, we're gonna have a lot of kind of free time towards the end of the talk, and I'd really like to answer your questions. I'm really glad to talk to you about mathematics and